Hey everyone, let's continue with 8.1. This is page 4. We get to what's called the ambiguous case. It's the SSA. The reason it's called ambiguous is because if you're given that case, you could have 0, 1, or 2 possible triangles. The reason for that is if we look at one scenario, this is a scenario where you're given, let's say you know A, B, and angle A. Right? So we know angle A, we have B next to it, and then we're going to put A then opposite. Right? Now, depending on the length of A and as opposed to B, you may have no triangle, right? Because A might be too short and you won't be able to reach the other side. Right? Or A is just right where you could swing it 2 ways and maybe generate 2 triangles. Right? Or you could also get 1 if A is super long, right? And you wouldn't have enough room to swing it the other way. So to outline all of the possible cases, and when we're looking at these charts here to help, it's always that these 3 sides, these 2 sides and angle are given. So to go through that kind of carefully, here's where you'll have no possible triangles. That's just when A is too short. And it's too short if it's less than the height of that triangle. And the cool thing about that is it's pretty easy to figure out the height because that's just right triangle trigonometry. So I'll write a little formula for that actually, because if you think about that right triangle, the sine of A is the opposite H over the hypotenuse, which is in this case B, right? Or so H is going to be B sine A. So you can do a quick calculation of B sine A. And then if A is less than that, there's no triangles possible, okay? Now, if A equals that exactly, in this next case, then you get exactly 1 triangle, right? Because A is the height, as in that picture right there. Or if A is just bigger than B, right? So in this case, A is larger than the side over here, B, then you'll get 1 as well, because there's no other possible way to draw the triangle. And then you'll get 2 if A is bigger than the height, but less than the B, right? That's when you can do that swinging thing. You can actually draw 2 possible triangles. So this is why it's called ambiguous. You have all these possibilities, and we'll go through examples as well with some actual numbers. Now, these are all the acute possibilities. Your angle given is acute. What if your angle given is obtuse, larger than 90? Then there's just 2 possibilities. Either A is just too small, in which case you have no possible triangle. You just can't draw that triangle with the given information, or it's big enough, which just means it's larger than B, and you have 1 possibility. So notice when I'm looking at these, I'm just focusing on all of those comparisons of sides. They also talk about sine B is this and that. I don't really worry about that when I'm trying to decide which case I have. Okay, so let's look at some examples and we'll refer back to that table. This says, which of the following sets of data does not determine a unique triangle? Unique triangle just means there's 1 possible triangle. But we'll just actually go through and just figure out how many possible triangles there are. And then we'll choose the ones that are not 1. So how about that first one? So when I draw these, so it's consistent when I'm comparing or when I'm looking at it, I'm always going to put angle A at that bottom left-hand position, right? So if I'm drawing A, A is here, okay? And then B would have to be, I'm going to always draw that there. And then A is opposite big A, right? Okay, so that's what's given. Now notice here for part A is bigger than B, right? A is 8 and B is 5. So that's what I have drawn, right? So that's that last scenario. A is larger than B, you have 1 possible triangle, right? So this one would be, let's just write them over here. That one has one possibility. Right? If you, on B, if you switch the sides, if A is only 5, right, and then B is 8, well, then A is just going to be too short. Right? It's going to be a scenario where you have something like this, right, where that A is just too short to reach the other side. This is fixed because that angle has to be 127. And so there's just no way you can draw a triangle with that given information. So that's 0, not possible. Okay, so those are the two possibilities when you have an obtuse angle. How about an acute angle? So the acute angle scenario, if A is 30, I'm always going to draw that bottom left angle 30, and then here's my B, and here's my potential A over here. Okay, so I'm looking at this scenario. For these scenarios, it's good to find H. Okay, and so H is always going to be B times the sine of A, like we saw above. Okay, so let's look at C. I mean, we may need this for some, we might not need it for others. Like for C, for this one, we've got A is 8, B is 5. So here's a scenario where you just have A really longer than B, right? If A is longer than B, that's this scenario right here, right? And that's 1. Okay, so if that opposite side A is longer, you're going to get 1. So this one would be 1. Okay. For D, we've got it the other way around. So now A is the shorter one. A is 5. So if we have 5 here and 8 here, how's that looking? Now, if this side over here is shorter, okay, it's possible that it just doesn't reach, or it's possible that you can swing it 2 possible ways and get 2. All right, so the key for this is finding H. And my H is going to be 8 times the sine of 30, which if you calculate that, it's equal to 4. Okay, so A is bigger than H and less than B. Do we have a scenario where A is bigger than H and less than B? That's right there, right? A is between H and B, that's 2. That's the kind where you could possibly draw 2 triangles like we have here. You have 2 possibilities for that one. The next one, we have B is 8, but now A is 2, which seems kind of small, right? So this is a scenario where it's probably like that, right? If that side's 2, I'm just getting kind of messy here. Let's do it this way. And this is 8, right? It looks like that, okay? We still have this same H, right? H is 4. So this is a case where A is smaller than the H. It's just not going to reach. That's a 0. Finally, that last one, A is 4. A is the height. Right? So that one, you'd have this scenario. You have exactly 1 triangle, right? Or that's the case here, right? It's that one. Okay, so take some practice getting used to that. If I answer this question, which of the following sets does not determine a unique triangle? Well, it's all the ones that are not 1, right? So B is not a unique, D and E would be my final answers for that. But really you're practicing trying to figure out how many possible triangles. Okay, now let's just keep practicing with that. How many triangles are possible with the given parts? Now you're not given AB and angle A anymore. You might be given some different ones, but it's still that SSA case. My advice on these, always still draw it the same way. So I have that same picture. Now I'm just going to put angle B down here. So my given angle is always that bottom left. So that way it's always sort of the same configuration. And then C would have to be here, right? And then B is over here. Now I have to decide, okay, what do we have going on here? Well, B is less than C, right? So can I first reach all the way over? And if so, is it possible to do 2 like that? You know, and that all depends on what H is. H is going to be the side adjacent to the angle given times the sine of that angle. Regardless of what they're called, it's always the side right next to the angle times the sine of the angle. And that height is about 13.9. So this is bigger than 13.9 and it's less than the 19. That's 2 triangles. That's the kind where you could swing it in 2 directions, or it's this one right here. A is right between, there's my son's game popping up. A is right between B and H. Okay. How about 5? So again, oh, we got an obtuse triangle. So I'm gonna put the 147. Oops, we'll just do it right there. 147 there. That's angle C, which means I'm gonna put A right here, right? And then C is this. Notice here, C is just too small. It's not going to be able to reach the other side, right? So this is that scenario here. Right? A is less than B, or in this case, it's just 36 is less than 40. Okay, so when you compare that, this one would be 0 triangles. Okay. So you'll have some of those where you have to find, and anytime you start a problem, you're going to try to figure out how many triangles. This one's asking a little bit of a different one. Just we'll find the unknown angles. We're going to take it a step further. But we're still going to start by drawing it and figuring out how many triangles are possible. So for this one, I always put my given angle down here. And then the side that is adjacent to it will be there. And then over here, 8.5. Okay. And then if that's B there, this would have to be angle B, and that's angle C up there. Okay. Let's see, how many triangles do we have? Well, this is the scenario where that side is longer than this side. So that's 1 triangle. Okay, so now I should be able to find these angles. Right, and I'm going to do that with law of sines. Okay, so notice you have 58 is opposite the 8.5. Right, and then angle B is opposite the 6.2. So setting this up, I could do 6.2 law of sines over sine B equals A over sine A, 8.5 over sine 58. And there's the setup. My recommendation now, you could do a little cross multiply from algebra. Right, so now we're trying to solve this equation for B. So we get 8.5 sine B equals 6.2 sine 58. Okay, divide both sides by 8.5. So now we'll have sine B equals all of that divided by 8.5. Finally, how do we get B? Well, it's going to be a sine inverse, right? So to get rid of that sine right there, we're going to move it to the other side and do sine inverse. Like from chapter 7. So we'll write that over here. B is going to be sine inverse of all of that stuff. And again, this should be a thing where you could just put it all into your calculator at once. I could bring up my calculator and try that. So here is my calculator. I've already put it in degree mode. And now I'm going to do first step sine inverse. And then within the parentheses, I'm just putting everything. So 6.2 times, now I got to do another sine, right? And then put a 58 inside that parenthesis and then divide by 8.5. Close the parenthesis. And I'll get that angle 38 degrees. It says round to the nearest degree, so that's about 38 degrees. Okay. Okay, and then once I have that angle, then I can find the third angle, the C, by just the 180 rule. So let's go back to the handout. And I'm going to do I kind of ran out of room, but it's okay. So I got my 38 right there, and then we're going to squeeze it in. C is going to be 180 minus the 38 and the 58. So I'm getting an 84 on that for C. Okay. Let's try another one. So we got find the unknown angles in the following triangle if it exists. Okay, so we got, again, drawing this out. There's my 35. So B's got to be right next to it. 3.25 over here. That's A, B, C. All right, just go for it. Now, if you want to do a quick calculation to see if there is even a triangle, notice here that A is smaller than the B. So it is possible there's no triangle when that's the case. So it might be worth your time just to do a quick calculation of H. The height of that triangle is going to be the 5.5 times the sine of 35. Just to see. Okay, that's 3.15, which is good. Well, maybe it's not good, but that means that this is long enough. So that height is 3.15. That means 3.25 is long enough. Here's a scenario where you have two possible triangles. So we need to get two sets of solutions for that, right? For the so kind of B sub 1 and B sub 2 on this one. Okay, so let's go with the first one where it's this way, where B is acute. Okay, and then we'll find it where B is obtuse. Okay, so we're going to set up our law of sines. Let's maybe blow this up so I don't run out of room. Probably I'm going to run out of room on this one. But I'm going to just start it down here. I have sine. Oops. Sorry, I've got B. A, which is 5.5 over the sine of B equals 3.25 over the sine of A, similar to how we did the one above. And then I'm going to cross multiply 3.25 sine B equals 5.5 sine 35. Okay. And then you're going to divide both sides by 3.25 and then take the sine inverse of that whole thing, right? So if I wrote that out, B is going to equal sine inverse of 5.5 sine 35 all over 3.25. There's your B. We'll get an approximate for that. So going to the calculator, let's see, we got sine inverse, blah, blah, blah. Just doing it on the handheld right here. I'm getting about 76 degrees. Okay. And then I can get the C by the 180 rule. 180 minus 76 minus, what was the A, 35? Okay. So 180 minus 76 minus 35 is 69 degrees. And that's one solution, right? So I'm going to call all those solutions B sub 1 and C sub 1. So I'll put a little sub 1 on those. Because there's the other scenario. Remember, there's two possible triangles. It could go this way, in which B would be an obtuse angle. The way to figure that out, if you know that the acute is 76, to get the obtuse, you just subtract that from 180, right? So geometrically, this angle right here would be 180 minus that one. So my B sub 2 is always going to be 180 minus B sub 1. You can always think of this as a little formula if you have to find a B sub 2. It's 180 minus the B sub 1. Okay, so in this case, we have 180 minus the 76, which is 104. And that's your B sub 2. And then C sub 2 is again that 180 rule. The 180 rule for the entire triangle. 180 minus 104, and then minus the 35. And I can maybe do that one, 39, 41 degrees for C. Okay, and that would be my other possible. So the ambiguous case, when you have two triangles, that's the most work. But basically you do it the same way as we did the other one, but then you have this additional step of finding that B2 of 180 minus B1. All right, fun stuff, right? I know it's a little confusing, but practice with it, you'll get it. Let's do one more for this video. That's going on a while. Let's see what we got here. Well, maybe this one's going to be short. Okay, 22. B is 15.7. A is 13.2. Okay, so definitely A is shorter than B. So this is a scenario where we're either going to have, it's going to be able to reach, in which we'll have 2, or it's just not long enough and we'll have 0. To figure that out, let's find H. The height of this triangle is 15.7 times the sine of 22. 15.7 sine 22 is 5.88. Let's call it 5.9. Okay, so this is definitely long enough, right? So again, we're gonna have that 2 scenario case. We'll run through one more. I'll go through this a little bit faster. I'm finding this B sub 1. Right, we're doing 15.7 over the sine of B equals 13.2 over the sine 22. Cross multiply, divide by the 13.2 and take the sine inverse. Do that all at once. So B is going to be sine inverse of 15.7 sine 22 all over 13.2. Okay. Let's see what that is. That's about 26 degrees. So that's B sub 1, 26. Okay, and then C sub 1 is 180 rule. We're going to get 132 for the C. Okay. And then what if B is swinging this way? Then to get B sub 2, my other solution is going to be 180 minus B sub 1. which is 154. And then C sub 2 is the 180 rule for a triangle. 180 minus the 154 minus the 22. And that's going to be 4. It's a little guy. So there's your 2 triangle scenarios. Whew. Okay, there's your ambiguous case. Let's take a breather. We'll stop there. And we'll continue with the next page in the next video. Okay, bye.